tell you,
It's pretty simple.
you guys like to take these kids for a ride.
Carry the 1. 1 plus 2 plus 2
See if I can get in here.
It's 50. Okay, simple enough.
Okay,
now,
so this should be my next part. This will go back to that logic gate that I had before. That one where we're going to get into the logic gate of it here in a second.
So we've got that converted.
Yes,
Send that
maybe.
into the XOR gate.
No. This stuff, I'm going to line it up the best I can.
It's called a full adder.
Full adder. Now that's super important for what I'm doing. Because, don't you dare. Okay. Now, I should have another picture of the other stuff somewhere around here. You're gonna have to study. I mean, there's no getting around it. You'll have to watch this stuff, eat, sleep, and drink electrons for a little while. A couple of days solid. And just to figure out this basic thing was pretty tough. You know you need them, right? You know you need diodes. A resistor is kind of a diode. We'll get back to that one. I had to redraw, or indicate the resistor on the first page. I kind of gave you some of the schematics of here's an LED and here's a transistor. But you're making all those logic gates which do individual transitions or changing in field or combinations of those things that make it work that way. Like, you'll need this because the diode is a resistor. They're both NP relative to each other and how the field works. And that's what I believe is happening here, because you really get this line and you get like this line here of the capacitance to deal with a timing issue or a alternating current to a direct current, and that is a type of timing. So you get into that fourth part of it, which is realistically two circuits running together, and of course I just got them hooked to a hot line. You know, magnet down, this is the open relay, this is the closed relay, this is a solid state relay with the photos. Like, because the physics here is what makes the thing collapse, and that's where you get these latching relays where all this kind of stuff and how that orientation plays makes really good mathematical sense. Because you know it's kind of, well, it's a capacitor, it's a polarized capacitor, so it's got the ceramic ones. Then there's ones where the charge is a state, or what, you know, how beefy that the individual materials are, have an up and down zenith, and then taking that concept to a a timed capacitor. Maybe that's like, it has to be on a time sequence, more about the energy dissipation, because then you get into, what is it, silver, copper, and gold, and which ones you doing numerological in thermal conductivity, or are you doing numerological in electrical conductivity, because they change the numbers around and the order of the materials potentially depending on how many's in that set group, which you'll need for things. So again, let's see if we can just kick this up here, make sure we get it up. Oh yeah, we're over here. Hi there. Okay, so the bunny farm here. While you're doing a lot of this stuff, see, he's not going to get, I chose the breadboard because it's a better variable. We could do this stuff, but what will become practical later at some point in time while testing some circuits and parts and materials, you could test them this way, but it gets a bit tough with soldering and wiring and then the mess. This is a way cleaner way to do it. And you can build each of these types of kinds of circuits almost a little bit here. Here's the diagram for this one here. Here's the diagram for this one here. Here's kind of what the diagram is doing, and it's doing these and or functions individually before we get into the exclusive and or. Well, that's an and. And or exclusively and. And that process is super important. super duper important. And or exclusively and so it would. Now in LEDs and batteries, obviously not at this 9 point, you got to get the resistor right, but it should still work. But when you get into things that are a little bit more serious about what this is, you want this diode on there. and the resistor to make sure that it doesn't jack up your gear or send a current back through this LED or the orientation of that LED, testing the multimeter on all these parts is basically, again, material composition between material composition. Bleh. 1, 2, 3, 4 real things, but really there's a wire involved. So there's 1, and then the ends of that connection, 2, there's 3 and 4, 5, 6, 7. That's why you get that weird 3, 5, 7, 11, 8. It's weird because they're a compressed thing like binary, and basically what I figured, and remember, for me this is about psychology, not about electrical engineering or programming or anything like that. So the game was to figure it out, what's a fun physical way that the geometry, because as you go explaining something, there's a nature of that solid state relay that's kind of happening of, well, somebody's extrovert or an introvert, and I would like to get this back off onto the concrete farm and stuff, but still super practical because you'll be doing this kind of stuff, either the physical assembling the thing where I don't necessarily need to know all the electronics, I just need to know parts and maybe some basic common problems that come around it. And then we can kind of figure out, so on the breadboard factory, if I want to do something, yes, Bunny Rabbit, that is the way you do. Appreciate. Now, don't eat anything and go back to being normal. Matter of fact, just pretend you didn't see anything inside here. So she isn't very pretty. This one's not too bad. And I had to pack a switch in there because, and you might have to know a few things to really get her to shine for her. And once I get this logic gate, I'm thinking in here I might split this down in half to have it the way I had it before, put that back, or I'll compress it in the first brick, all this in that first brick, and I'll do 2 phases and I'll connect it up like a bunny rabbit, right? I want it to be the square hair, but we'll move these up over here, and then I can just run that into this up inside of there by the circuitries. I know, right? Big Daddy Ben Eater, I'm about to break the rules. Come on with the farm. But if you get into that MOS chip, or that 555, man, holy crap. Oh, and these and/ors. And these are specifically those and/or kind of chips that help you do that. And by some, you don't see it. It's a different field. Where did it go? It's a different field, but what we're doing is open relay, closed relay, conventional field, electron flow, and it's really there, and it's a hard thing to truly get. Now, I know somebody's going to say, electron flow, that is exactly what it is. And it's like, well, testing things and it actually serving some purpose for the elevator, or, for me, it's a switch actuation done. We could turn this into an actuator, right? Not just a relay. There's this and the other stuff with the wires that get you into the field and the magnetism and the heat indexes on things that you could invert test. Oh man, this is I love it. I was just trying not to get sucked down in the black hole again for something different. Anyways, catch you on the next one. No, I'm having fun.